So I just start the recording. Okay. So I just a request to all of you, the participants, that I had already shared the steps of downloading the Tecla software from Trimble website as shared by Satyam himself. So there is, you can download it and the software is free for 1 month, right, Satyam?
Yes.
Yes, so you can I think you some of you have already downloaded it, but some queries were coming to me. So that's why I'm just making it sure that you can download it and you can practice the session, whatever the Satyam is going to teach right now. And then if you having any kind of a doubt and having any kind of a queries related to that, you can directly contact me. All of you are having my number and email ID, I think from mail, as well as the contact number from the WhatsApp group. So you can contact me and I will forward the queries to Satyam. And I think he will revert it back as when to the earliest as possible. So that's a small request from my side, because as Satyam has already said, BIM is you can say that one of the most important software presently, and not as a point of, I think, structural engineer, but I think as a civil engineer also. For the basics, I think everyone should get into this particular software and learn, so that as on our, uh, mm, ourselves, we can do a good, and for the benefit for the students also who are going to step into the, this, industry, and we're going to face a total different world after, from the college. So I think that will be helpful for them also. So it's a humble request from my side, that take the maximum benefit of this particular session, because it's a twofold, you can say, that beneficial for us as well as for the students also. So Satyam, the stage is yours. You
Yeah.
can share your screen now.
Thank you, sir. I'll share my screen so we
Yes.
can start with the session. Is my screen visible?
Not now.
Let me check. Okay. Is it visible now?
Yes, it is visible now.
Okay, fine. So I have shared with this what are the basic steps how we can download Tekla structures. If anyone of you have might installed, so we have Tekla structure icon. We have latest version of this Tekla structure, that is 2021 edition. If we open up that software, we get this window. So right from the basic, I'll start. Uh, so we'll get this window. In this, we have different sets of environment. So while installing, we'll have some blank project, default environment, and India. Whatever country project we want to choose, we can have that environment. It is freely available on Tekla website. We can download it from that role. So we have talked about like every other person is using this software. So roles you have to decide what we can use: contractor, engineer, precast detailer, rebar detailer, steel detailer. So let us choose all for the role for now, if we hadn't decided any role for yet. And yet configuration we can leave it for now. We can use whatever it is displaying, because it is directly dependent upon you have subscribed to Trimble website and you have made your ID, and they will issue your educational license over there for one-time use. Okay. So after entering it to the software, We have different tabs like recent. If I had prepared any model, it should be over here. All models, shared, and new. So what if we have to start with a new model? So because we are beginning, so we don't have any recent obviously. So we'll start with a new model. We'll assign a name to a model. Let's say I'll assign it as practice session, and we can place it over there. We have a choice like where we want to keep our model, whether it on the desktop, but it is preferred to have like make any folder to store that, because all that files will be displaying on that particular folder. It is better to assign one folder to it. So the name which I have assigned to the model, I'll same will be giving to that folder. Okay, so we'll use it as a single user. We don't much go into that details, single and multi, but I'll give you a brief about that. Like single is like if I'm only the one who is working in the model, so that will be single user. And multi-user if number of people like working with this model. So what if my model is based in my computer is is a server for that model, and I have shared to this another person who is working on some different part of building. So I have to make it multi-user so that another person can work on real-time basis. And there's one facility also, Tecla sharing model. So shared model. So currently the as I'm working remotely, so I'm working from home. So that is like power of BIM. I can work from home. I have my laptop. So I'm working with a Swedish client with the help of this shared models technique. So my model is on the cloud, like any cloud, you mean you can say consider as like Google Drive, or they have their own cloud based storage. So over from there we can choose to have like cloud modeling services, and any of the person whom they have rights to access, then can work with a model. So these are the tabs. Now we'll enter the software template. If someone has their company's template, they can choose default that, or else we can leave it and we can make our own template. So we'll stay with the blank one, and we use this one. I'll give again this name. Okay. So in beginning, it will take few minutes to open it up, because it will access all these files and all process that. So depending upon your configurations of your PC, it will open it up. You can, if you are facing such error, you can leave for now because it takes some time to process it up, or it might be there like some of the file might be missing while installing. So it is giving a message to me, you are using an educational license. After this model, it can be used only for educational purpose. Do you want to save the model? So for the like Tecla Trimble, Tecla is a software which is like paid software. We don't get access to it like directly without paying the fee of that user. But if we want to learn it, if we have to start learning it, we can have educational version. So we have to make sure like we are not using it for the industry purpose. So it should be like only for the educational purpose, and it won't be opening in the regular version of the Tecla. So you can't do some production ready things in the educational version. So I'll click yes to this model. I'll ignore this error for now. Okay. So we are into the software right now. So it's popping up Trimble Connect. I'll talk about this later. What is Trimble Connect? So yeah, so this is the interface of this Tecla structure, how it look like. We'll talk about the features and functions one by one with the software. Starting from the file menu, what three lines describe is it is file menu. In this, we generally provide the input regarding the like setting up the units to project properties, location of the project, whichever information we want in our drawings to be incorporated. So new from this, like once you have started with the model, if you don't want to open a Tecla again and you want to start a new model, so you can directly press new and you can start with the new software, a new model. You can see, you can create new model without opening it up again. Then open. If you you don't want to again click another tile of Tecla structures and you want parallelly to open a new model, so you can directly open from here. Like if the program is being recently opened, so you can choose recent model, all models, or you can browse the particular location where you have kept the model, or browse shared model. If the model is on the cloud, so you can directly take you on your ID on which you have registered to the Trimble, the model is being shared and you can directly join from here, that cloud model, and you can enjoy working on that. And after that, there's this printing. What it command says, oh, I've skipped save as. Yeah. So after open, we have save as. In this, you have to regularly save the model to get your work stored in a single file, and save as. If you want to rename the model or you want to keep two models, you can save as the model, save and create a backup copy. So yeah, while we are working, so it day by day, the model size get bigger and bigger as we add the information data set into it. So we have to create a backup of it, so that if the model get crashed, obviously it can happen many times. If the model get crashed, if it get too much heavy without any knowing error, so we have to create a backup of it. Save model, save as model template. If you have some template, you can save it as.
Okay, Satyam, just a second.
Yeah.
There's a hand is raised by Aftab, sir. It is
Yes, sir.
just
Hello.
हाँ जी
Yes.
Aftab sir.
Yes, sir.
Actually, I have downloaded this software which you are giving the
Yes.
introduction Tecla structure, but all these icons are not shown to me. Means in my software icons are different as yours.
Okay. Did you have downloaded the education version?
Yes, I have downloaded the Tecla structure design trial.
Okay.
So is
Uh,
it the same?
no,
In
sir. It is
software?
on. No, actually, I have asked for Tecla Structures 2021. It is not the designer one. It is the modeling one.
Okay, okay, okay.
Yeah.
So is there any option so that I can be on the same screen as you are shown to us?
So I think you have to download it again to the website. I have shared the steps as well. If you are feeling the issue somewhere, I can help you out. You can share your screen afterwards, and
Okay,
I can help you out. Don't know.
it's mean Tecla structure design is another one,
Yes.
and Tecla structure is another one, and Tecla text is another.
Yes, I have discussed like previously this thing like Tekla has branches. So under that branch, three softwares come: TEDS, structure design, and structures. We are having like session of Tekla structures for now.
Satyam, what is a basic? There's a question actually comes. Sorry to interrupt you again.
Yes, yes,
There's a question coming that what is the base difference between the structure and structural designer software? As you said, there are three branches.
yeah.
So, what is the difference? Basic difference between these two? Hello, Satyam, am I audible?
Yama, you are audible. I think Satyam lost some his connection.
I think so, ma'am. I'm just connected. Yes, he had some. He just left the meeting. I just had a word with him. Yes.
I think there was some internet
Okay.
issue.
Yeah, you
Uh,
are here. Okay, it's fine.
yeah, yeah,
Yes. Can you just answer that and then we can proceed?
yeah. I'll answer. I'll share my screen and can answer.
Okay. Okay.
Yeah.
Okay. Okay.
So yeah, you can see the interface like we have different tabs: steel, concrete, rebar, drawings and report, manage, and analysis and
Jay.
design. So in this Tekla structures, what we do is we model, we with its nature of building, whether it is a concrete or steel type building. So we model that, and after that we extract the drawing or like production ready there are production ready files as well, which directly go into the shop drawing factory, and over there they will be casted. So it is compatible to that. For analysis of that particular model or particular project, we use Tekla structure design, TST. This is short form of Tekla structure design, TST. From that, only the analysis part has been done on, and geometry will be created over there. If someone want to have like don't want to much waste of the time like making geometry again and again, so in the Tekla structure design will model basic geometry. The designer will like model geometry, and then they will put the analysis load and all, and calculate the nature, and do the analysis over there. But it won't be handling much of the analysis part, so we don't make much use of analysis and design part of this Tekla structures. I think that makes a difference between both of them.
Okay,
I hope.
Satyam. Yes, yes, yes. I think it's fine. You continue and then we'll see if we have any queries and we will take up
Yeah,
with the end of the session.
sure,
Okay.
sure.
Okay.
Okay, okay. So over here we have like printing. We can print drawings and reports. Reports is for like extracting what type of bars we have, the schedule for the bars and everything. Print drawings, we can plan. We can print the elevation plan and shop drawings from this command. You can see the interface as well. Like we can do the printer settings. Either you want to have like in file in PDF, we can directly make that model and convert that drawing to PDF format, like to send it directly to the factory or to the contractor whom they want to use. So we have different option as well, what type of nature we want to have extraction, like document manager. Okay, then we have like a model folder, open model folder. So in starting, we have generated one folder for that model. So over here we have loaded the model folder. So in this folder, we have
I think Satyam, you are there?
Yes, sir, I'm here only.
Okay. Internet is creating a problem.
I think, sir, I have joined the internet, like I've connected it.
Okay, okay, okay.
Yeah, I hope it shouldn't happen.
It's fine. It's fine. You can
Okay,
proceed. Yeah.
okay. Uh, I've shared my screen. I hope it is visible.
Yes, 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 Satyam. It is.
Okay. So lastly, we were on model folder. Then we have import types of file we can import. We generally use this CAD models if you have, and DWG files and DXF file, whatever format we have, like whether it is DWG or DXF, we used to import that. And if we have in any PDF, we can directly insert that. We used to have insert reference model, like I have shown previously in my presentation. We have MEP model. How we coordinate is like reference model is very good tool to add that. So we add from here, and we can see how it looks like. Okay, and export. IFC is very good function. I have to we have discussed about it. IFC, industry foundation class. So what basically IFC does, so whatever we use to model in this area, so this will be exported, and will obviously we won't be showing that all of the sharing all of the model to the owner or contractor or whom the person is concerned. Will share in some simple format so that it can be visible to everyone. So that IFC helps us to convert into the simpler format. Like DWG and CAD is for drawings. Like we can share all of the software to the person. We need some specified file format to make it readable, human readable. So we'll use IFC for that, for IFC for model. As I was talking about project properties, while starting off project, we will assign some number like 1,000. It is their name of the project. So I'll name it as practice builder. I'll leave it object, region in which it is located, the project, city, the whatever fields you have at data you have, you can put it over here, and it will be directly helpful in generating the drawing. The if designer wants information, some specific set of information in the drawing, what we use to send to the contractor, so we can describe it over here what we have. And after that, after filling that all important information, we need to have that location. Like on the real-time coordinates, we want to have to start that project, or is it like we can start from origin axis? So if we have northeast coordinates, like from total station, we generally have that coordinates of the building, like what are the specification of the building, where it is located. So we'll provide that northeast coordinates, elevation, latitude, longitude. We'll provide all that dimensions. Otherwise, we can start from the origin 00 axis. We'll skip that part and we'll start from the origin axis. So these are the basic project properties we want to have, and we can start with that thing. Next is settings. In that thing, we if we want to modify something, let me show you an example. So but this area, it is called work area. The box you are seeing, it is a boundary of that area in which you will work. If the person can need to start model, so the person should have some boundaries, some specified area of work. So this is called work area of model, and this is grid lines on which our drawings are based on, and we start modeling like where our footing will be, and whether it is eccentric to the grid, or it is on the center of the grid. So these we can all manipulate, we can make a change as per our drawing specification. And as I have clicked upon this thing, this boundary box, we have uh, different information like name. uh, we can see it is a 3D model, so name is specified to 3D. Angle is, we have mentioned to 3D. We can change, we want plane, 2D plane, we can change. We need to have 3D plane. We have projection, orthogonal or perspective. Will the perspective is like it will diminish while going to the behind, and orthogonal, it will be same from all around, will keep same. Obviously it won't be visible for now. I'll when we'll start modeling, we can see the difference. And visibility depth, like how much height should be above it and how much it should be below, so that is there. So these are the basically, for now we have the default settings. Okay, so now we'll see some basic ribbon settings. After that we'll quickly see, and then we can start some modeling the thing so that we can relate it. So in this ribbon area on the top, which we have in the default, we have steel as an option. We can start with a steel column, beam, steel beam if we want to have, plates, bolts to connect them, or weld to make them connect the two steel parts, and items if we have specified items in the project. So this all section covers steel. And next is, if we have concrete building, so we need concrete elements to be there. Concrete column, beam, wall, slab, and from the footing we have everything. And the item, if there is any not a specified thing, or want different concrete item which is not like the regular ones, we can put it in that background. Edit, if we want to see some changes, like if we want to have like cut in the beam or column or slab, use that thing, fit part. So to having like we generally use it in the steel to fit it up. Chamfer, we generally see like slabs are made chamfered. We do the at the edges. And if we want to after edit, I'll move towards, wait, I'll move towards measure. If we want to measure, like let's see, if we want to measure from one point to another point distance, we'll pick one point from the left click of mouse, and we'll terminate it to the another point. And then we can out of this space, we can terminate it by clicking another again on the left mouse button. So this is the measurement tool. Copy, if you want to copy one object from one space to another space, we have different range of options for that. And move. So as I've talked to you about work area, so this covers the work area. So we can, this is the default view, but we can select and we can alter it as per our requirement. If we want to shorten it up, we can, if we want to see this a small window, we have used this option using 2 points. So we pick, so this is in like we can't see anything. Why? Because we have shortened it up. But to bring it back again, to we'll select this. Wait. Yeah. So we'll use this to entire model in all views. So it will bring back the entire model in the window. If we want to make it shorter, we just pick and drag to which location we want to see again. We have just a basic closure look of that. So in this particular area, whenever we open a model, it will show only this amount of area. The elements which are attached to this view will be visible. So I'll bring back it to the game because we need an entire model. Okay, so these are the basic tools, basic command list, which are there. There are ribbon is full of many commands. Like as we get used to with this software, we'll learn how to tackle all these commands. So we'll you try to cover these commands one by one. So I will start modeling one footing. I'll pick up a footing. Before footing, we can see the grid, but after the work area, we will model that footing on the grid. So grid is a very important part in any project. So the designer or the person will see like how will be the geometry and how they need to divide building. So they will plan some grid system, a grid coordinate system in that project. So after setting up that grid space, uh, obviously this default grid won't be using. We just press double click on that, and rectangular grid is option available here. If we want to have different type of grid, we can use that as well. We can just simply go to the grid option in edit. We can use a create a radial grid, create a rectangular grid. If you want to add a grid line, we can add that. Uh, so we'll going to we'll choosing the rectangular grid option for now. So this is rectangular grid. So if we double click, we have this rectangular grid option. Now we don't want this default grid to be there. If we want to modify it, how we'll do it? So default is like if we measure 6,000 cross 6,000. So we want is like somewhere 3,000, somewhere 4,500, somewhere 5,500. We'll pick up this grid. Firstly, origin is 0, 0. So we have 0. And after for entering another coordinate, we have to make a space, provide a space over there so that it should pick up another coordinate. Without space, it won't be picking up another space. So it works accordingly, like a tab or space, you can say. So to have it another dimension, to add another dimension. So we'll set it up on 3,300, and another I'll pick it on 4,500. See, just I'm providing the space to separate it. 5,500. So you can see I have taken up 1, 2, 3, and 4. 4 grid lines. Over there are 3. So now you can see the difference. So we have 4 grid lines over there. We have made a change over there. On origin, we have A grid. Then on 3,300, we can relate it to the B, because labels are also mentioned over here. These are the default default labels. We can alter it, like we have made a change in the coordinates. So over B, and then third coordinate is C, and then we have another grid line which is not labeled. We are seeing just a blank. We are not seeing like any label on that. We have to name it. So we have added one grid line. We'll make add D. So we have 4 grid lines over there. So it works on the axis. We are on the plane right now. So there are three axes in the software for now: x-axis, y-axis, and z-axis, which is out of the plane. That helps us to create levels of the building, z-axis. So we have made a change in the x-axis coordinate, like these are the vertical grid lines. So along the grid axis, they have made a change. So on the y-axis, what we have three grid lines again, which are on the default side, and 6,000, 6,000 each. So we'll make again change over there. We'll add 3,000, 4,000, and 5,000. So again, we make a change in the grid in the y-axis: 1, 2, and 3, and 4. Fourth obviously is not labeled, so it is not showing it up. So when we have, let us check like whether we have the dimension we have provided is correct or not. So again, from measure tool, you can pick it up, endpoint 1, endpoint 2, and then anywhere in the space, you can press the left click of the mouse, 3,000. Again, we can check by measuring it, 4,000, and again this. So as you can see, we have made a change, and we this thing, and this is parallelly displaying the results. So that is the like power of this software and BIM. Like we need not to change in any drawing, since we have not made any drawing, but it will be parallelly reflected to drawing as well, and we'll label it up also. So we are seeing a coordinate grid system over there, rectangular grid system. Now we have talked about like x and y axis. What if we want to add planes in that? We want to have different set of levels, because building will be obviously there would be some stories, multi-story, whether it is a G plus 1, 2, 3, any which of it. If there is a basement, then we also provide it. So I'll talk about ground and plus 2, 3 coordinates. So we'll add some plans over there. Like I'll take height of the building 3,000 first, and over there, yeah, I missed that thing. So in the coordinates, I need to make a change, not in the labels first, so that I can able to see 9,000. So on the zero axis, that is the ground floor, we consider the first floor, second, and third floor we have. Accordingly, we can make a change over there, 6,000, 9,000. And you must be wondering, like on the z-axis, can we make only digits, or we can add single digits? We can add text as well if you want to specify it more. Like I'll add GF to it to make it much more easily readable. Because these are labels, we can make a change obviously over there. Okay, now we have seen the labels and levels we have set accordingly. So in this work area, we are not able to see any of the levels. We are seeing just only one level, because uh, it is on the view 2D plane. If we have to see the levels, we want some different views. We want some different levels to see, to access those levels. So will we create Hello.
Yes, yes, Satyam, continue.
Yes, it has some great feature, like in the view as well. We can create views along the grid lines. So in this tab, we can see like from where, which location of the plane we want to have coordinate, we want to have views. Like we have seen in the presentation, we have like we generate a model and we can see the view from everywhere of the building. So this is like setting it up, doing the settings and some tweaks in that before modeling, entering into the modeling. So X, Y, Z, Y, XZ, which part of the like grid system or coordinates we want to see, which axis you want to see. And if there is a radial grid, we can do that changes. Since we have rectangular grid for now, we'll use this and create. So previously it was empty. Now we have got list of views over there. Now it is bit relatable, like whatever grid we have created, we have got the views for that. We'll look into it like how it is there. A, B, C, D, F, F, that is first floor, ground floor 0, SF, third floor. So you must be wondering why it is not coming 0 before 3000 and vice versa. So uh, it picks up the alphabetical letter first, and then it moves it to the next. But it it is in the display views, but it won't be there in the list because we have 0, 3000, 6000, 9000, and so on. So let us pick a view over here. There from we can check. I'll take inside of the grid a view. So we have created levels 0, 3000, 6000, 9000. Ground floor, first floor, second floor, and third floor. So there we can check. We have levels. We have proper levels. We have what we have did in grid system. If we want to measure it, it is being automatically shown by this parametric direct modification tool. So we have that grid system over there. There are many more features as well, but for basic, we'll keep it now this ways. And origin, if you want to shift your grid from a certain location, like from you have coordinates, you can put it over there, or you can specify while starting of a project, you can provide the base coordinates. Accordingly, you can start your grid. Now we'll move back to 3D and we'll see the grid system. So now you will must be wondering like why all these dimensions are visible, and will they be appearing in the drawings? What will we create? The plans, will they be along the drawings? No, we can just right click. We have different options. Move entire fit to entire model. If your model area is big, you can pick fit to work area, and this work area will increase, and we'll press redraw for it, and everything will go away because these are the temporary dimensions. These are not the fixed ones. Okay, now we have made our grid system. So we'll start model like about from the concrete will pick up any footing will pick. In the footing, first I'll talk about like what type of concrete element is present standard. In the concrete, we have seen column beam, but there are further classifications as well. Like there's a single 2-point beam, poly beam for different shape of the beam, spiral if there is any curve in the beam. So we use spiral beam. Panel, wall panel, what type of panel it is, layout if you want to continue modeling more many walls, one in a single click. So you can use wall layout, slab, what type of slab it is, floor layout. If there is a plan, we can start and directly use it as footing, what type of footing it is, pad footing or strip footing. So I'll start with a normal pad footing. So you must be saying like it is clicking or it is picking up these endpoint, midpoint, point of intersection. So that why it is like picking up those panning to those coordinates. So we have this toolbar that is called snap toolbar, because it is snapping to midpoint, endpoint, and intersection. So we have to use this snap toolbar to adjust it. So I have made it turned on, snap to points and grid intersection. So that's why it is panning to point, intersection, endpoint. If I turn it off, it won't be picking it up, pan to a grid point or intersection. It just regularly picks up an endpoint. So snap to intersection point I had turned on, so it will just pick to midpoint. It won't show the intersection, whether it earlier was showing intersection. Okay, so I'll choose pad footing on the center of this area. So on this area we have pad footing done, and this is like a default size. I hadn't given any size to pad footing. I just clicked it and just model it, because Tecla has some basic default settings, so it picks it up on, and you have to alter that as per your requirement. So the we have toolbar for that. To adjust that, we have settings for pad footing. So we have name. We can specify whether it is F1, F2, F3. So I'll just name it as F1. So profile we have 1500 cross 1500, means like in the length and the width 1500 cross 1500. If it is not like symmetrical, we'll make change. We'll have 1200. So you can see from the center it has been reduced. So now it is 1200. Width has been changed. So it is width cross length of this wall, length of this footing. So if we change this dimension as well, so now you can see 1200 cross 1100. Material, we have different profiles as well for the footing. So BL, and if these are the standard default profiles for different type of elements. If you want to use this the concrete type, different type of concrete shapes, and if I talk about trapezoidal side or this side, we can use that. And we can see there's a color provided to it. It is like a very you can assign colors on your choice. So or either like a senior person can advise you like whether what color of model you want to have, like what how you can specify elements with the help of colors. So we can specify, so that comes under class. So I have given this green color to this, and I'll change color of this as well because I want to specify differently. I hadn't made change, that's why it is not visible. Like I pressed 2, but I didn't modify. So it won't be changing without modify. So now it is changed. So we had talked about color, profile, Then comes the material. That is the important part, like which grade of footing you want. So as per the Indian standards, like I have choose the Indian profile in the beginning. So I'll be getting the Indian standards, Indian codes. So there's like grade M10, M15, M25. We'll use for the normal construction, we use M25, M30. So for the footing, we'll use M50. So that we have assigned to this material. Finish, we leave it for now. And then comes the position, rotation, horizontal, top and bottom, how this will be. So I'll switch it off direct modification because it won't be displaying the start and end points. We hadn't talked about like how this work, like how this is like one click option, but if we have to create from one point to another point. So this software works upon this these 2 points, this yellow and magenta one. So any element, if you have to begin modeling, you just press you start from this one and terminate it to this one. So yellow is considered as a start point, and magenta is considered as endpoint of this model, of this element. So footing we have like seen like it is one click, but if we want to have beam of certain length, so this is a start point which I am giving point or intersection it is demanding. So it automatically gives instruction when you start model as well. Pick on the bottom you can see pick the end point of the beam. So you see the beam was created, pick the start point for another beam to start creating, press escape. Now I have finished modeling beam. I don't want another beam to be modeled. So it is still in the beam mode. You can see it is already selected. So if I want to have beam connected like from midpoint to this point, it will still have beam. It won't have any other element. So I just press escape to switch to other element, or else I can direct press to the other element to model it. But if we don't have any other element, we don't model, we just press escape. Okay, so we have footing over there. We have start and end point. We have seen this position like vertical and rotation on the top. Vertical is middle. Will if we figure it out, like if I change to the down, so it will change in the y direction. Like vertical is for this element, it is this direction. So it has moved from middle to the down. So it has made footing my eccentric. So it is not on the center of the grid. So you can directly change it by, instead of moving this footing from this place to this to make a certain move. So you can directly choose this. The rotation, it is on the top. You can make front, how it will repair. So it has rotated. If I move back top, so we have made a change like this way, front, so it has moved this. So I'll keep back to top, horizontal. If it, so horizontal is like in this X direction. So in the X direction, it is in the middle. So I want it to be in the corner. I'll move it to the right. So it has made some shift to the right. So if I made it to the left, so it totally makes it to the left. So that's how you can play with that modeling skills and that tools. You can use that. Top is 0 for now, and bottom is 500. Why it is in negative and why it is not in positive? Because this end point is that ways, and the bottom is minus 500. On this, it is bottom 500. If I want that to be up, so I will revert it 500 and bottom I'll make 100. So you can see earlier it was down. Since I made a change to that, so it has brought on the grid. Before it was not above the grid, it was below the grid. So it was like this way. That's how you can modify like what is the position. If I want to increase or decrease the height of the footing, so let's say it is 500, I want make it more add more depth to it. I want like 800 footing, so I can change. So that's how you can make it some geometry change. Obviously it is we have assigned like footing, and we have made a change over that. Now this cast unit numbering, cast unit, once we start working within the model, we can talk about the numbering, cast unit and portfolio. We can leave it for now, this thing. Basically we can focus on the these modelings of the geometry. Will, because these are related when we once enter into the drawing phase, we have to number it accordingly. Nature of the building, whether it is cast in place or precast. So we decide accordingly. For phase, we keep it 0 for now. So that is for the footing. We are just talking about for now the geometry modeling, how the geometry modeling works. Now we have modeled one beam from one point to another point. So whether the beam will work same as of footing, we'll see the interface of the beam as well. So it already displays concrete beam, but we have selected, so it has opened up its properties, what type of beam we want. So its name all by default, it is beam profile 800 cross 400. So what is 800 cross 400? What it actually means? 800, so it works like depth cross width of the beam. So depth cross width. So if I change it to the 600, if I say, and if I made it to the 300, so it will make a change. Whatever depth and width we want, so we can alter accordingly. Material we have seen. Class, if I want to make it apart from this thing, we can change the class. Then position, what we want. Middle, top, behind, we have seen in the footing. We can see it here as well. It has made to the right. I'll make you see from the top. Position on plane, because we are seeing on the plane. So in this part, it has made on the right. On the left, because along this direction where it is making a change, along right or left, I'll keep back it to the middle. Rotation, from where it wants, front, so it will flip. So now depth has become width. Now again depth and width back on the track. So depth, it will be behind, middle. We have option front. If I choose to front, but how it will be. So from front, it has being on the top. Behind, it will straight away take the bottom. I'll keep back to the middle. So however you want to set the modeling, you can alter that accordingly. You can obviously add the dimensions to it. At the depth you want 100 millimeters, say. So it by default will show you if you like it should be 100, and you can copy that and paste all across. You can from the grid you want 100 millimeters, like at this distance, it will show like that from the middle. position we have seen. Now, I didn't talked about the end offsets. How are they? So I have talked about like start and end position, but I didn't talk about end offset, like in the direction X, in the direction Y, and in the direction Z. So how they behave. So I'll bring back to the normal. So it is in the middle. So if I add some dimension, how it make a change? 200. So offset is like removing some distance or moving it to the distance from this part. So it will create some gap from there. And if I add again a distance at the end, it will move. But if you want to make it backwards, what you will do? So we'll add negative to it. So it will move backwards. So minus sign helps us to like reverse the thing, and in the positive you don't have to create a sign, but it moves in the positive direction. That's how, like if you have column over here, let us consider column. So you'll give some distance to it. So it automatically like I'll modify it. I'll just copy the property of it and model one beam. So I don't have to take another mark another beam like that ways. I just copy the properties, and similarly I can use the beam all across my grid. So one needs to set the property like this is one type of beam. I need this much distance from the edges. I can set it one time and use wherever it is required. So what is in the dy dz? So if you want to choose in some width, you want to alter it this way. So I choose like 50 mm. So it is shifted 50 mm. You can see there's slightly turn over there. And if I want to make it more slanted to this side, I can make it 50. Sorry, this 50. So it is twisted like this way. If I want to align this way and don't want to have like much of the width this way, but this would we generally have like at the center of a column. So I move it back. Similarly, within the Z direction, if you want to some increase or add some height from a standard coordinate. So we will make a like default structure with a footing, column, and beam. We use footing. One is centric. One will be at the center. I must consider. So middle I'll choose. So it will be in the middle, and will be symmetrical footing. On this way. I'll delete this beam and make a footing to that. Okay. So, but if I need to start a column with that as well, because it is in the bottom footing, and now I to start with the column again. I'll take point of intersection at that place, and I want to align this column to the footing. Either I can have a choice to move, or I can choose it to have down, because it will make it offset from the center to the downwards. Then I will adjust the height of the column. What will be the height of the column? What will be the width? So if it is 1200 by 1100, I'll modify. So I will take it as like 500. Cross 600. V cross H. So yes, you can see the difference. We had made a change over there. Call call for material, I'm taking M30 now. And height, I don't want height of 5000 because that is a basic height, default height for that Tecla. So I'll have a height of 3000. Then we will copy this column to another grid. So we have this in the edit function. When we'll move, copy edit, what we have seen, copy special. So linear in one, like in the plane, like at a specified distance, we can copy in XYZ direction. Mirror, we can copy plus mirror to add a mirror to it. Like we want this column and we can mirror it to another place. We can use that. If we want to switch or flip, rotate any object, like don't need to have in this direction. We want to rotate. We can use this command. Another object, if any item is connected with this thing and we want to have some other way, we have to connect with another way. So another object, we can use this option. So these are some another commands, like we want using it for now, like from another model. So if we have created some object in one model, that type of object, and we want in this model, we can copy that. Okay. And what if we have this model to be copied in all other footings? Copy to another object. This what I'm talking about. I'll just press this. It will just take up its original location and we can just mark it up. This and this. So we have column, but it is not as per our requirement. So we just take and middle, we can alter it. So it is not in the middle of this. We have to make some alteration changes. Same way we can move it. We don't have to make it again and again. We can just double click it, copy its property, select it and modify it. For moving it, can directly move special. Oops. Or at the last, we can simply copy and pick a copy point to this and this way. So this is how we have connected our column and footing. But if we want some we want to add beam over there, how the beam nature would be. So lastly, I have selected this beam and use this property. So that's why what Tecla does is it stores the last configuration of an element. So we have to make a change, like it will pick up the last property. So over there, we need to delete those dimensions as well, because we want to have connected like end to end. Since it is modeling, we are using the 3D plane, that's why it is coming in the bottom. But we can alter it and we can make it to the top. and then we can connect this beam. And in the periphery, we can connect the beams. Like snap is working very well in this. It is helping to connect from one part to another part. So we can see a frame structure, like column, footing, column, beam over there. They are all connected with that. So we want the column to be terminated at the bottom of the beam. So what will we do? We will reduce the height of a column to a certain, we'll measure like what is the beam depth and how much we need to reduce. Since we have depth of 600, we'll reduce by 300 millimeters. So for lowering it up, we need to have 2700 millimeter height of the column. So we need to decrease the height 2700 millimeters. And same with all other column. So I'll just copy these properties and modify. And modify. Or else I can copy all of these columns at a single thing and paste it like a single click. And I want beam to be at the center of column. So like how we have make it off center, we can change it to the center of the column. Minus 200 and 200. Same with this way. Minus 200. Here it is increased and 200. So it is creating a clash over there. So we need to change that as well. So clash we have seen like over there, like overlapping is being there. So it won't be like adjusting itself. So we have to make some change over there. So we'll make a change with that. If it is not fitting it properly, we'll shift the beam backwards. For now, like 50 mm is clashing. So I'll just increase by 150. Over there, I'll see the space like how much it is. 100 I have space, so I'll increase by 100 millimeters. And over there, I'll increase by minus 200. Since I'm not finding like very well fit, so I'll adjust this as well. I'll make it to the middle and column as well. Make it to the middle. And now for the beam, I'll move this endpoint to the middle. I'll reduce this by 150. 150 from there. So we have used like footing, column, beam to create a frame structure, and then we can use a slab over it. So we can see all this dimensions are being used in If anyone wants to have like feet inches, many of the architects use the dimensions in feet inches, we can use that thing as well. We can convert the units in feet inches as well. So in just settings and options, we have modeling dimension, units and decimals. Over there we can use simply feet inches. All that thickness and everything will be converted to feet inches. And for the catalogs as well, we need to change it to the feet inches so that we can have that compatibility of both of the things, like modeling and using the catalogs. So we were on the slab, but how slab like will be modeled in this area. So for modeling a slab, we need to like it's a point toolbar. It will go from one point to another point, and whatever how shape you want to have, like we need to have minimum four corner points you need to have for the slab. So you can go beyond that, like if you want to change the geometry or you want to have the cuts, you can model it like that ways. But I am having some simple geometry, so I will take like four corner points. One is that, and terminate it to the point where I have begun. Since I'm modeling it in a 3D, that's why it's going beyond, but we can move it upwards. We'll give some height. We have this slab. So slab and beams are flushing for now. They are on the same level. I've kept it on the same. So similarly, if you want to have like more number of columns and more number of footings in this way, you can just simply click this. Yes, click these two options and copy, use the copy function and just measure the distance, pick this distance, copy, and again from here to here you can copy, you can extend the structure that ways. Like if you want to have beam from here to here, you can copy. I might have given the wrong distances, that's why the beam is not there, or the grid, yeah, over there like grid is not equidistant, so and that's why it's overlapping. So we need to make some alteration for that. And over there, points are on the grid, but we have given some offset distance from the start and end point. That's why it's like not on the exactly there, because we don't want to avoid the clashes. So that's why it's like visible like there. I will make some change that ways. Can I again copy this? And again, if we want to have slab, we don't want to create another single point slab, like from putting all these efforts like 1, 2, 3, 4 points. We can simply click copy linear, that, and we can make some changes over there. We just select one point from where we have to stretch, another point. So how we can create a geometry of a model. So these like columns I have used rectangular. We can have circular as well. It's depending upon like what type of shape you want. So we can use that ways. So if someone wants to have like this not length and breadth, we want to have this circular dia. 60. 100 millimeters. I'll again I to increase by 600. So we can have that column as well. Okay, so if you want to use this as a single item, like column and footing, not copying each of the elements one by one, so we can make it as a single unit. So we have option create a cast unit. So it will give the instructions like the objects you want to include into the cast unit to create the cast unit. So it depends, like you want to add column into the footing or footing into the column. It depends totally upon your choice. So I'll pick footing, and along with that I'll pick column, create a cast unit. So I'll pick this one and this one. So I have picked up the footing and then added column into that. So I'll press the middle button of the mouse. So it is like single unit. It is like assembly. So over this, you can see this. These are the individual ones. These are not the single. These column and footing. But if I go into in the object component over there, I can copy it as a whole. Sorry. So I don't need to pick both of them. I can select this assembly and this. So we have talked about this snap toolbar. So I'll describe you about this as well. Like this is another toolbar in which we have switch options like select all. If I press this, I can select many of the things. So it enables me to select all of the objects over there. Like this we have another toolbar, select parts. If there is any other parts, we have points. If we have different points over there, construction lines, we sometimes we used to have reference lines as well. So we can, with the help of this, we can select a reference line. If we have, this is the select model reference symbol. If we have reference model, we can use this and select grid. If I enable this, then I can select this. If I turn it off, like if I select the select model, you can't choose to have grid. So this allows one thing to be selected at a time. If I press this. So I can choose many of the things parallelly. So I'm not able to select the grid because I had turned it off. But what if I've selected all and select the grid? You can select that. So similarly for the welds, since we had not modeled any weld, we won't be seeing any weld. Cuts and edit material, select views, bolt groups, rebar. If there are rebars, we can select the rebar. Loads. So we don't require the pour breaks and loads for a while. So I'm not suggesting you this thing. And these are the select component. So everything, these ribbon is full of this component. Like column itself is a component, and assembly, I can say, like it which has certain set of information, that is a component. Like the column, it is a component. And objects in component. So what if I have attached a rebar, and if it is not attached to the column itself, I have modeled it, but it is not attached to the column. It will be different parts. So if I have modeled the rebar, I'll show you. Let us use column component. So this is another component, application and component. Uh, These are individual. Since I select objects in component, I had to select one bar. So I had to use this option because I had added another part in it, like another component used in this particular concrete element. So itself, like it's acting a whole component. So if I choose ring in the component, I'll use that part. If I had to select whole of the thing, like footing and all, so I hadn't made the footing reinforcement, it is showing automatically. So we had to alter this as well. So wholesome, it is showing the reinforcement, reinforcement for the footing, for the column, it in the assembly. So it has been turned down to a one single unit assembly. So if we want to have like rebar, if we take a look about the rebar for the column, like basic rebar modeling, we have two options. Either go to the rebar and make one by one rebar in it, model rebar in it, or else we can shorten up our work and use directly column applications and reinforcement. Some some might be available, some can be made. So that will, if the process is repeated, so we can make components that is on the later and advanced stage, how to make an application and components. But by the default, we can use this rebar group to model. So I'll pick up a column in which we can model see like how the rebars look like. So since I have made some geometry, uh, I want to be modeling rebar in it, we need to have separate view of that particular part. Or I made like, I'll pick this part, select assembly, so that whole of the area shouldn't be get into the another view. Create view and 3D view. So I want to make it separate. So I just created the one 3D view for the component for this particular column. So now what type of bar will be in the column? So we have seen general reinforcement layout, like vertical bars we have, and then we have the rings around it. So we'll take that bar group. So pick the shape of the bar, what type of bars we require to have it. So we'll take from bottom to top. So I have given the shape of the bar like it should be straight bar. And then from the middle button of the mouse, I'll press terminate and indicate the reinforcement. So suppose if this column has 4 bars around the corners, so the range should be either on this way to this, from this way to this way, or this way to this way. So I'll pick up the longer range first. So from on pressing the from range, giving it to the range, it has displayed some bars. And these amount of bars we don't require on this longer side of the column. So I'll switch. This is the snap plane. So view is like a view plane is like front view of any this particular area. If I consider it as work plane, it will change like from where I can work. Like on the plane, on the plan I need to work. So it will switch it back. So I'll alter it. So we have seen the grade we can change. FE500D, we generally consider it. And size is 10. On the corners, I require to have like 16 dia bars. I can change it. Bending radius. So as per the default settings, as per the default IS codes, it has bending radius and the list of properties attached to the bar. So I can modify it. So I can I can make furthermore change. I want 25. I can 25. Make it 25. But I don't want a number of that bars. I want to make it reduce. I want such bars at the corner. So I'll be using, so there's a distribution method over there, equal distribution of bars and equal distribution by target spacing value. You can make a target, like you can provide the spacing value, exact spacing, like at which end you want require, like number of bars cross the spacing. So there are different options you can choose to work. Like I'll choose exact spacing. So I'll calculate like how much distance I want. Sorry. So 600 is there. So let us calculate like I want a cover of 40 millimeters from all of the edges. So we have a concrete space of 600 minus 80, 520. So in 520 we need and exact spacing will set and on plane and form plane. So on plane, if I change this, so from the edge, how much it is inside, how much it need to be moved, like this is the end point. So how much it needs to be inside there, and if like on the default it is outside there. If I want to bring it to the right side, so it will be moving like that ways. So that is on plane. And the font plane, if I change it, see. So on the vertical side, it will help us to change 35. If I'll make it 50. So yeah, it will help us to add distance from the edges. Start and end. So start. So it has been given us distance of 25, 25. What is basically is like cover from the start and cover from the end, from the top and the bottom, but we have the cover it is. So if we measure the distance as well, we can take a look at that. And why we are getting 62.5, because from the center, 12.5 plus 50 millimeters, it is 60.5. Since we don't want that much, so we'll give a cover of we maintain the same. And start and end will also give the same 40, 40. And now we'll change the distance for that. We don't want to. So we want it at the edge. So I have provided some distance over there, and similarly, without modeling it over there, we can just mirror this bars. Sorry. So since I didn't copied this bar, so it has directly modified to the move. So I will make it mirror. It automatically has taken the endpoints of that thing, and on the edge I have got. Now we want to have rings around the bars as well. So we'll add more bars like at the center and this way. So we can add that bar as well. So if we want to have the bar at the center, we'll provide like that ways. And if we want to have ring, we'll just press the simply bar group. This column, pick the shape of the bar. Since like we have used the vertical bars, similarly we can make a shape of the ring. This we have to make a round, so we'll terminate out over there and there. And now the range from in this point to this point, because we want to have like all over the column, so we'll use that. Now you must be wondering like why it is giving the this thickness of rebar and not the proper one. So we have to make some changes, but before that, like last default bar we have used of 25 dia, it will be using that same thing. So we have to make some changes for the rings as well. So I'll pick up this and I will alter from here the size. So I want specification like 10 dia specification ring. So we have option in this rebar option, like I'll use 10 dia for this. And bending radius had automatically changed, but since I hadn't modified, so the die had not been changed. So now you can see there is noticeable change over there. And now I will change the cover for that as well. I'll make it to the 30 because 40 is for the inside bar. I need 30 for them. And I need hooks as well for them. 135, one at the one end and another at another end. So yeah, now we can see there is some overlapping over there. So I can make further more, or you can alter it that ways. Or you can move the bar from there. Now we want to have that all in that thing. So we can space it up like 10 at 100 spacing and 10 at 150 spacing and 10 at 100. Because at the end we need to have like closely spaced stirrups, and at like on the top and the bottom and the middle we can increase the space as per the codes. This is how we can reinforce our beam, footing and everything. Any reinforced like RCC member, we can model it and reinforce them. So yes, I had model over there and you can see like it is being coordinated over there. So like that ways I can have that reinforce. But if like all the members are same, so after modeling it, its geometry, I can simply copy all these bars, copy special, copy to another object. This way, this way, this way. So this is like a powerful thing. You can have all the changes done in the model, because the step is like firstly we model geometry and then we go for the rebar and then we go for the drawings. I think that would be sufficient for now, because we can practice it and then come to the and move forward after modeling these geometry elements. If we can take a look at the column. We have I section for there. We have different profiles like ISMB, ranging from ISM 100 MB to 100 and to the 600 section. LB, if we want LB, it should be there. And ISJB, ISHB. So it is as per Indian codes you want to have, and ISWB. These are the I section, I profiles. And if I connect one column to another column with a beam, so we'll have some junctions and connection with them. we can connect them. So this is the basic level of geometry modeling. We can see for concrete and steel. Rest we can learn how to connect them, how to connect with them bars, how to connect them bolted, how to get them welded. If I choose beam to column, we have connection. I think, sir, this is sufficient for now to have like geometry modeling for now. We can practice this, and if like geometry and reinforcement modeling for the concrete. Rest we can choose to practice. Hello.
Yes, Satyam.
I think, sir, we can to practice this on like I'm this geometry modeling is sufficient for now.
Okay, okay.
Yeah.
So, okay, it's fine, it's fine. We can do one thing that, so you were doing on structures, na? So as like you have discussed all the aspects of Tecla structures by
Yeah.
showcasing this model, right?
Yeah.
Okay, okay, then it's fine. So is there anyone having any kind of a question? So they can put up their questions. And there was actually, just give me a second actually. Yes. So there's one question is there, which was asked previously, that other than IS code, what are the international codes does Tecla support?
So we have Indian codes, we have Euro codes, American codes, Middle East, any pick up any country. So we can use any of the codes. Right now, I am using Euro codes. We have like in the default when we started Tekla, we have Indian version installed. So if we install like Euro version, we have specific countries like Sweden, Belgium, Germany. I'm using Swedish based codes, Euro codes. We are using any of the compliance. So that has capability used to use any of the codes.
Okay, so just for one curious question, that since you're working in Indian standards as well as you had worked in Euro codes and also, how what kind of a difference you find, the basic difference, if I want to ask you?
Okay, so in Indian standards, like what we have observed, like minimum ring size should be 8, and minimum dia of the bar, which we provide in the slab, is like 8 dia. Since we work for the structures like for the Swedish structures, so they have very less seismic zone.
Okay.
So India is like some regions are very high seismic zone. So we have to analyze it for the earthquake as well. We have to consider the seismic analysis. So they don't much prefer the seismic analysis, and we use in that like basic mesh of 6 dia. Over
Okay.
here, over here we don't find like 6 dia in the bars, 6 dia bars in any of the project you want to see. So from that like perspective, you can see like how much steel we can save over there, like using 6 dia bars even in the like proper full size slab.
Mhm.
or going it for the pre-stress lab. And difference is like in over there is like most of the construction is like precast construction we use. So in India, precast, like I wanted to cover some part in BIM as well. Like I have shown like precast projects with the use of BIM, so it is helpful. So over there, they use like prefabricated things.
Mhm.
So in the factory they used to cast, and on the site they used to put it everything without wasting any concrete, without pouring the wet concrete at the site. So whereas in India we are using like much of the like pouring process at the site.
Okay, okay, okay. So, okay, that's a kind of a nice thing, and I don't think so. Right now anyone is having any question, but one thing I just want to say that since you are here and you actually gave us a detailed difference between the various branches of Tecla precisely.
Yep.
And I think that when people are going to practice more,
Yep.
as the practice goes, then the things are going to come up. So I think they will be asking, and that's a perfect way to make understand, because I don't think so that you haven't left anything untouched. You touch each and every aspect. That's a really really a good thing in just a span of, let's say, 2 hours. So I think thank you so much once again, Satyam, for taking out the time from your busy schedule and give us the time and share this information with us. And I think I just have to see when ma'am is here, because she's also having some commitment. Otherwise I will do it. Yes, she's not here. So okay, on the behalf of Department of Civil Engineering, I would give you my deepest warmest thanks to come to share your knowledge. And to be very honest, as you said also, and one of the participant also said that Tekla is not that much of there in India, but I
Yeah.
think when you're going to see, it is coming now.
Yeah.
So, as a BTech graduate, or let's say even an MTech graduate, when they're stepping out of the institution, they should know these softwares and this. And definitely, I will be, calling you for more workshops and,
Sure.
on structures, even the designing and analysis. And all the participants, I'm having your email also. So I will definitely going to put you a mail of these workshops. And I hope everyone, you will join. So for just, I just give you all the permissions, everyone, to unmute their mic. And if they want to ask any query and want to have any kind of a question regarding that, so they can ask. Otherwise, we just, we can close the session. The feedback attendance form for this session has already been posted. So you can, fill this session up. So, um, I think there is no query. They will, I think, first, experiment with the
Yeah,
software.
they like let people should experiment and
Yeah,
come up with the queries.
yes,
Not a problem. We are
yes,
ready to help and solve the problems. So
yes.
it's not an issue.
Okay, Satyam. So thank you so much once again.
Thank you,
And
sir.
we will be, communicating very
Sure.
soon. Okay.
Yeah, we'll be in
Okay.
touch. Thank you.
Sure, sure, sure.
Thank you,
Okay.
sir.
Okay. Bye-bye. Bye, bye,
Bye bye.
bye. Okay. So, dear participants, tomorrow will be the last day. The first session will be taken by Dr. Rohit Tiwari from UNSW, Australia, regarding the geotechnical and transportation advances. And then we will be having our feedback, valedictory, and assessment. So, we're going to meet you tomorrow morning at 9 a.m. So, till then, thank you so much again for attending today's session. And we will be continuing tomorrow night. Thank you.